everybody. So today we're going to be doing the special guest edition of what might go on in 2025 in AI and knowledge graphs. And I am joined by two very special guests that I really admire. This is now the second year I've done this, where I have my long running segment that I've done with Alan Morrison and Kirk Hagel, and I'll link that down below if you want to see what we all have to say this coming year, as well as what we've said in the past, see how well we guessed the trends that are going on in the knowledge graph space. But last year, I was joined by Margaret Warren, and this year I am joined by Amy Hodler and Paco Nathan, two people that really are such, first, just beautiful and wonderful individuals, but also crazy off the charts smart. So when I get a chance to talk shop with those two, I am certainly a happy camper. So without further ado, let's get into what they think might be in store for 2025.
My name is Paco Nathan. I'm at a company called Sensing. I work in any resolution, especially for knowledge graphs. And yeah, I've been in the graph space for a while. I have a long background in machine learning and natural language, and I got into working with graphs because of natural language understanding.
I feel honored to be both on the show again after a couple of years, and then Paco, just honored to be with you as well, because amazing minds. Great to be here. I've been in the graph space for probably, I want to say, around 10 years. I have worked at a couple different graph companies, and recently, I guess about a year ago, it seems like it's gone by fast, I founded a community called Graph Geeks. You can find us at graphgeeks.org or on Discord, where we're just trying to get people together and talk about graphy things and geek out, because Paco has the sticker. Awesome. Thank you, Paco.
All right. So today we're going to be talking about, we had a session with Kurt and Alan before. We were talking with our annual, chit chat on, the different graph and data trends for 2025. And today we're going to do something similar, but these folks work a lot on the AI space and, the interplay between some of those graph use cases and what's actually going to happen in the next year anyways. So with that, let's kick it off. So some of the things that we keep seeing, right? Everybody's talking about agents. And I know, Amy, you actually were bringing up something a little bit different, more about intentional. Or no, what was it? You said it at Connected Data London, and then you just did a recent post on it. But you were talking about some other way of using graph, and I thought it was really fascinating. Can you remember what that was?
Yeah, I think even beyond inference, kind of causal graphs.
That's it. Yep.
That's been a thing I've been fascinated with over the last maybe year and a half, 2 years. So what I find interesting, so I think there's a correlation, or at least maybe kind of adjacent to some of the operational graph and the agentic workflows that we could probably do a whole show on. But this idea of taking advantage of the structure of a graph to understand how things are related and dependencies between things, not necessarily to look up or to query a graph, but to use it to actually compute over and to do kind of a machine learning and inference over. So I've been fascinated with this idea of causal graphs. There's py.org, if you're interested in something, along that lines, based on Judea Pearl's work, which is, focused on, and actually he invented do-why, which is calculus to compute why things happen, and that's all cool. But you need a graph structure to say, what event leads to another. You need that arrow of why. And I'm really excited over the last, I've done a couple of talks on this topic, and I would say over the last 2 years, I'm seeing the people who are attending just increase and expand, what areas. And so from a graph person, it's really exciting to see the application of graph as more than just a data repository that I'm going to look on. I'm actually going to use it to compute things. So that's an area that I'm fascinated with, and it's exciting to see people actually get excited about it as well.
I think that's why I was thinking it was intentional something, because every time you say that, I think, okay, you are intentionally going into this graph modeling with a very specific thing, right? Yeah. So I love that.
I love this area of causal graphs, and I was really looking forward, and I really, really enjoyed, Amy, your session at Connected Data London about that. We see in use cases, like if you're looking at fraud, like you're at a bank and you're looking at, there's an incident, and we know that like some servers are taken over and bad things are happening. The thing is, you can think of like causal graphs as kind of being using the graph for like placeholders. Like, that if an attack is occurring right now, they came in somewhere. Where's the node representing where they came in? So I'm hearing more and more in use cases where they can use like causal graph analysis as kind of a lens to, alongside even things like maybe GNNs, to try to say, can we predict parts of the graph that aren't there, but we know they need to be there?
Oh, I love that. It's interesting too. You brought up fraud detection, and not to deter from more on the causal graph side, but I am seeing so many more interesting applications of the fraud detection and graph analysis, but for totally different use cases that are very, side-eyed to fraud, right? So how can you trust that this person who is presenting this article or this video isn't AI generated? Could we potentially look at the graph of a network and see like if they connect, and what if it goes to nothing? Oh, is that a shell company or a fake person? Kind of sort of the same, right? So it's really interesting to see how other areas are starting to like grapple with this same problem that we've seen in the fraud and graph space, but in a totally different, application of it.
It's interesting you say that, because I do think there's a lot of there's some similarity between, how as a human we decide whether we're going to trust somebody we've recently met, or a company or a brand. And a lot of it is context. It's like, is this related to what I was looking for? Is this person know somebody I know that, that I trust? What are the signals? And I think as a human, you get these signals and you process context without realizing it, and you make a judgment. And so it's interesting to see these contextual fraud-ish items that are related to trust. And at least today, I just feel like trust is such an important thing in our lives, and anything we can do to improve that, I am very supportive of.
There's a definition of trust that I really love. I'll dig up the author who came up with it. She has a book about trust, but it's like our relationship with the unknown, and like, how do we really navigate that? And I hear a lot of different definitions of like AI trust, but really, what are the unknowns that we're having to grapple with, and how do we really feel about it? I'm also like, fraud is just it's really fascinating to me in some ways, like horrifically fascinating. But a decade ago, I was leading data teams working in e-commerce, and there was credit card fraud. These days, though, I hear about stuff of like people running all kinds of weird insurance scams and like retail coupons, making money off of like retail, and it just crazy schemes. But there's just such a diversity of it.
Yeah, there's a new shocking story around every corner nowadays. I feel like.
Yeah.
But you were also mentioning a little bit about how do you understand the lack of, right? If something is missing, how do you understand that negative space is actually supposed to be there? It's so funny, like when I talk about negative space, and Amy, you just were talking about like artists. They naturally think about this, right? Like there's a negative and a positive and a foreground and a back, like all these different things, because they understand like the layers. Because of my YouTube channel, I have to do lots of things in Photoshop. So now I know lots about layers and how AI is in there doing stuff too. But it is, back into that, the unknown. Well, how do you know what you don't know? And how do you know what you don't know is okay and doesn't actually exist? Right? It's kind of like FOMO, but for data and analytics.
Data FOMO, new term. Sorry, go ahead.
Data FOMO.
What I was a friend is at a large pharmaceutical. They're working with graphs. They do a lot of work with graphs, but lately they've been working in rare diseases. And he was just doing a talk about that, because with rare diseases, you go to the doctor and we have no idea what to do. But the pharmacists are starting to figure out that they can build graphs and find like genetic similarities with better known diseases. And
Mhm.
again, like grappling with the unknowns and where can we try to fill in the blanks and come in with something. It seems very promising that this is an area that graph and AI will make a lot of progress on.
I think there's a lot of discussions going on right now about latent knowledge
Mm.
and how graphs can kind of help see, like the truth is there, or the thing is
The
there.
truth is out there.
Yeah, the truth is out there. Oh, I couldn't help it go there.
Sorry.
We just can't
Ah,
see it. And I mean, knowledge graphs for a long time have, people have used knowledge graph completion, to try to say, what are the links that we don't see. But I think there's also this kind of latent data, latent information that you can infer based on structure.
Mhm.
And that I've been fascinated, and I can never remember who I talked to last about, but I'm fascinated with this idea of hierarchy of information, and that there's latent space out there. There's latent information that, if we can understand the relationships and the structure of our data,
Mhm.
that then you can infer other, into other spaces or other hierarchies, which I think is, as Paco said, is just really promising for, for moving forward.
Amy, I am so happy to hear you and others, right, talking a lot more about that space because, early in my career when I was still, on shaky, Bambi legs with my graph skills, I remember coming into the graph space having worked in auto classification, which has a lot of taxonomies, hierarchical taxonomies involved with them. And there was a lot of inferencing and things that we had to do, in that space. So when I came over here, I remember talking to a very prominent person in the graph space about how there is hierarchies and you can infer things based on where they belong and how they nest together and all these different things. And they ripped me apart. So this person is still very prominent in the graph space, so I won't mention their name. But I just felt like, oh no, maybe I really don't understand this. But again, as you get more experience doing this yourself and understanding the real use cases, I don't know, maybe I was just using the wrong terminology and there was contextualization issues when I was doing that initial talk, but it makes sense. Like everybody on the planet categorizes things. That's
Yeah.
how we work.
Yeah. I
levels of
think,
abstraction. Yeah.
yeah, and I think,
Let's do that.
maybe 5-10 years ago, that we didn't really have easy ways to represent or abstract some of the hierarchies.
Hmm.
And I feel like there's things coming along more recently in doing like hyperdimensional graph embeddings, and where you can we can do some really complex abstractions of these layers and then do things. So maybe you were just ahead of your time.
Yeah, absolutely. Yeah. Well,
Thank you.
I mean, it
Maybe.
is something I've heard a lot over the past year, especially for enterprise use cases, where if you look at the whole graph, it might be billions of nodes, it's meaningless. But a thing that's been asked for, and you're starting to see some vendors starting to approach it, is like levels of detail.
Oh,
Can
yeah.
you, just like in Google Maps, can you zoom out and still see some structure that stays consistent? There's a lot of math for this if you want to get into topological data analysis and persistent homology and all that scary names basically, but there are ways to do it, and people working in geospatial have been doing this forever and ever. So I think that we'll see more with graphs of like, if there's a pattern, can you collapse it into like a condensed node? And then instead of looking at 5 billion nodes, now we're just looking at a few hundred.
So you were talking about some of the scary stuff. I will give one practical example on how to test and learn some of the things that you're talking about without the scary part. I once took a course that did this, and it was so instrumental. So you have your class, and you're sitting wherever. Take them to an interesting place, not a classroom. So like sit outside or somewhere where there's some interesting things. And you ask the students to talk about every layer that they belong in that moment. Right? So, okay, you're on this campus. Maybe you're in, near this road, you're in this town, and then in this state, you can see it in this universe, right? And you can keep going up into these abstractions of where do we all sit in any point? And then you add in, but the world is moving. So am I in that same place that I was 2 seconds ago? Like, so it was this really interesting thought process And again, like maybe if you're in the graph space or the geospatial, you're like, yeah, of course. But it was very instrumental to folks that I was with in that time because I was not in graph at that point, that it made me start to realize how things work together, right? So it's just a fun, practical thing to try to do.
That's great.
I'm wondering if there's, I've often thought that there's a lot that graph practitioners can learn from geospatial, practitioners. I don't have experience, or I'm not deep at all in geospatial, but it's just logically, as Paco, you were talking about, and then Ashleigh with your story, and I'm like, it seems like there's a lot we could learn, and I don't know what the first steps in doing that might be. What do you
Oh,
think?
So
Oh,
I will
oh,
shout out. There's a really wonderful organization. It's called ESIP. I think their URL is esipfed.org. But it's like an umbrella organization for the geospatial scientists at NASA, NOAA,
oh.
USGS, some USDA, and others. It's what's called the Earth Observatory, basically
Mhm.
climate science in the U.S. And so there's a great organization. They have this huge Slack board. There's a lot of work groups, but in particular, there are multiple work groups on knowledge graphs. So there's a really excellent community, very lively community of people working with geospatial and knowledge graph at the same time at NASA, JPL and elsewhere. I used to work at NASA long years and years ago, but also NOAA, and I've done more
Mhm.
recent work with NOAA on this, and a lot of
Nice.
great reasons to be using graphs for this.
Yeah, I would say also adding to the pile of knowledge here, which is great. Um, and I hope he doesn't mind. I don't think he minds. Paul Cleverly, he's been on the channel. Amazing person that does graphing geospatial. Like if you want to go and see somebody that is super smart but also fun and like easy to approach, he is the guy, right? He's got so much cool stuff. He's always posting on LinkedIn about something else that's really cool. And I have learned, funny enough, he and I were going through our dissertations at the same time on opposite sides of the pond, and we ended up like comparing notes because we were doing like kind of similar things, and we've just stayed in contact all these years. So he's a fabulous person, and if you really want to learn and just ask like, where do I start,
Hmm.
he's going to guide you the right way. Yeah, he actually, talking about geospatial and like some of the real world applications of the combination of neurosymbolic AI and the AI and knowledge graph pieces coming together. He posted something recently that I found really fascinating, where they're actually using graph data and geospatial data to help policymakers in the UK understand about the underground architecture of everything, to understand like what's the implications of what's going on, and just educating them on what's happening. And I think he's using some um, data visualization in there, and there's a bunch of other applications that he's using. So more details on his page, but it was really fascinating. I love hearing the stories where the big ticket items, that there are big organizations, big governments, big, whoever is doing these things, that are using this data to make more informed and educated decisions. And that always makes me really happy.
Well, since you brought up policy and government, one of the things, and I'm curious if you two have seen this as well. One of the things that this last year that I've seen shift a little in the graph community, or I'd say maybe knowledge graph, is just more use cases around legal, regulatory, kind
Hmm.
of understanding. Not necessarily enforcement. You wouldn't want to, you'd want a human involved, but just kind of understanding the regulation and how things ripple through, or legal research, if you're working on a case and things
Hmm.
like that. And it's interesting because it's not necessarily something that's splashy for like a news story, but when you think about just the amount of stuff, uh, big organizations have to, or legal teams have to sift through, you're like, oh, I get that. Like it would,
Yeah.
be helpful. So I'm kind of, yeah, I didn't see, like 2 years ago, not so much, but now I'm just seeing a lot of that.
There's a great case study came out a few weeks ago. Chia Yang wrote it. Also, Tom Smoker and others at a company called Waihow.
Hmm.
They were using knowledge graphs and GraphRag to understand transcripts from congressional hearings. Because,
Mhm.
I mean, you get like a new draft of a bill or results of a hearing, and it's just like hundreds of pages. No human can actually read that. So the point being, can we leverage the technology to try to make more sense out of lawmaking and policy while it's in progress? Actually had a conversation about this with one of the European MPs who was attending Connected Data London. She was there just to kind of get info about that.
Yeah. You know what? It's interesting that we're seeing a lot of it happen now.
Yeah.
And I'm glad about that. And maybe it's, right place, right time. I was working at a publisher, standards development organization for engineering years and years and years ago. This was my first, official job out of school as a professional. And I was very, very fortunate because it was a really great atmosphere there where they allowed people to learn and get engaged with things. So as part of that, there was this big piece where and you can even look, I literally just looked them up, I think, the other day, and it's, I think, called Swiss, SWISS. And I think it's Swiss, and you have to look up like standards or something else. For anyone listening, I will put a link in the comments below so you can find it, if Googling is not helping you right now. But it is something that I worked on in my past, and they're using knowledge graphs, right? And what they're doing, similar to the policy piece, is what happens before policy? Things are
Mhm.
standards or specs, and they have to be then created by the manufacturers or the people who are doing the work so that the regulations and things and policy can use them to then enforce or do whatever they need to do. And so a lot of folks like in the aerospace industry and the transportation industry, which is what I was working in at the time, when you're building an aircraft, you kind of need to know all the specs so it doesn't fall out of the sky. Just
Right,
little
yeah.
things like that. We're very good at hopefully not doing those things, right? Meaning things falling out of skies. But there are so many, similar to what you were talking about, Amy, but there's so many documents, standards, specs, and it's
Mhm.
like, well, is it this piece or it's that piece? And so what Swiss is doing is it worked with all of those standards development organizations, and you can grab the pertinent pieces of all those standards that you need for the vehicle that you are building, and then you look at from a graphical perspective of all the pieces, causal, which parts have to come before which other parts. And when
Mhm.
I'm saying like standards, they go down to like these nuts and bolts in this space have to be X. And so
Yeah.
all of that comes together so that when you are building that vehicle, it's going to be up to spec, it can pass regulations, and it's using all the standards correctly. And if you're really smart nowadays, you have a digital twin application, which also uses
Yeah.
graph, then to like model it and make sure that it's actually meeting those specs. So all this stuff is like coming together finally, and it makes me
Yeah.
super excited.
One of the NOAA applications I was talking about from ESIP, it's very similar. The idea is, they have a charter of doing measurements. There's a lot of implications about the measurements because, for
Mhm.
instance, international treaties about fishing and quotas for fishing are all based off these measurements. And, they get like a tax on buoys to change the sensors so that the court trials will go in a different direction. It's really absurd. But the problem is like you put these sensors out at sea and you're collecting data, and then 10 years later you need to replace a part and it's a completely different vendor. How do you align the data? How do you keep
Mhm.
track of like what was used to make the recording? Because NOAA has records going back over 200 years for
Mhm.
like soundings. And so yeah, it's and also with climate change and like
Mhm.
reinsurance and all that, it's becoming a pretty big deal.
Well, and it goes even like to supply chain too, right? You have to kind of know,
Yeah.
okay, I have this component, but that component has chips and stuff in it. Where did they come from, right? Like understanding all of that is also like a security
Yeah.
thing to make
Yeah,
sure
absolutely.
you're building with things you can trust and they're like, acceptable specs and all of that.
The other thing that's kind of, as far as like what's changing in the space, we're talking about like really complex problems, and I think we all geek out on that because it's like, oh my gosh, we can finally tackle some of this stuff,
Yeah.
and it's good to see the parts come together. But the other thing that I find interesting that I'm seeing is you're seeing very, I would say, light touch graph use cases come through where they don't need a lot of graph; they just need a little graph sprinkles on the
Oh,
top.
I love that. Yeah.
Uh,
Yeah.
and it's either, well, I don't need a I don't need to maintain my own database. I just need something that's embeddable, or I just want a little like graph projection on top to do just enough with, whatever's in my data lake. And I find that really interesting as well, because the more, in my mind, the more people, even if they don't know it's a graph, like maybe even better, that they're able to, apply some of the networky insights, that just gets it into more people's hands. They're going to be more creative. They're going to come up with crazy things we haven't thought of. And there's a lot of low hanging fruit out there that maybe isn't super exciting, but it's very valuable for people. And that's another thing that I've started to see is just different models for low hanging fruit, whether it's like, hey, I just need to do some investigations of a case study. Hey, I just need to correlate 3 hops out something. It's not like super, graphy, but it's just graphy enough to where you need to be able to add in a little bit to what you're doing. Yeah.
Yeah, I love that. And I would agree. I've been saying in my honest reviews for a million years, but it's always great when I see something that allows you to spin up a graph and then flush it all down after you're done, right? Like, give me the thing I need and then get rid of it all. And that's fine, right? If that's what you need. It's not always useful for everybody. But to your point, it's like these little, like, okay, I just need to figure this thing out. And especially with, the AI can like talk to your graph and all these other things that were not possible, or not easily possible, I should say, before. And now you can I love the barriers that are coming down, right? Because so many more people can get involved and start to experiment and do the things that you're talking about, Amy. It's fascinating.
Low commitment graphs.
Yeah.
I won't call them flushable graphs because that's just sounds awful.
Doesn't sound, yeah.
No,
Low commitment.
I would add to that. I mean, one thing that we see, especially in like fraud cases or sanctions compliance, anywhere like in the finance space or public sector space where they're chasing bad guys, basically, it's very similar to what you're saying, Amy. Is like you might have a really huge graph, but when it comes down to somebody actually doing the work, they're working with a case management tool, and they usually end up looking at like 10 or 20 node subgraphs, and that's all they care about. They just need to be able to explore that, and they can do their work. The trouble has been that we when a bank issues a suspicious activity report, on average it costs about $50,000 for each report. And I think early on people were coming in with systems to like generate these reports, and what I've heard is, we can generate a few thousand a day, but then you look at how much it would cost to like take action.
Yeah.
So that's one thing I think, this year we're on the cusp of getting really good at chasing bad guys. I don't know that there's enough money or political will to actually do it, but I think some of the open data projects are actually helping make a lot more headway, like open sanctions and, what Friedrich Lindenberg and folks are doing there. I love it. So I'm looking to more open solutions for some of these things that had been really just like public sector before.
Yeah. Anytime I hear that, I think of, you hear these stories of the data sleuths that are solving cold cases and other things with like Google Maps, right? Google satellite maps and things. I just feel like graph is going to get its moment like that this coming year, because combining what Amy and Paco just said, like, maybe you don't know how to use a graph very much, but you're now like getting exposure to some of these tools and some ways to do graphy-like things while starting to help solve for, fraudulent cases, or, something is not smelling right in a certain place. Of course you have to be careful, right? Like, we're also talking about, I hear a lot of folks say, yeah, well, we're also having this is not my opinion, but I hear others state this opinion, that we're in this space where we're having a lot of citizen scientists in the graph space now, some folks are saying like, great, now they're going to screw up all the graph stuff and nobody's going to want to touch it after they mess it up. So there's some of that going on, which is kind of a bummer. So like, you don't want to say, hey, you're fraudulent and not really know what you're talking about. So,
Right, yeah.
just assume you could be wrong and, do your due diligence, make sure that everyone can do it exactly perfectly right before they're allowed to, go off their training wheels. Or do you allow people to go and play, again, with boundaries, and see what they come up with and see how amazing and innovative people can be? think you probably all know which one I'm on.
I mean, a lot of it does feed into investigative journalism, and definitely there's some boundaries there between an actual formal investigation and like a journalist, but really a lot of it starts out because investigative journalists can ask questions that maybe no one else would ask.
And I think nature just kind of pushes us to that direction too. Try things out, fail, more people get involved. Castles in, often a beautiful, pristine location don't tend to thrive as much as like the crazy, messy, world that we actually tend to live in. So I just think as a practical matter, we're going to have more citizen science. It's going to be messy. People are going to make mistakes, but overall, things will move forward. A thought on the democratization of graphs in general. One thing I'm not seeing yet, or I'm just seeing like little inklings of now, is better interoperability between graph data and non-graphy data.
Oh, for sure. Yeah.
And in particular, like I've been thinking about, and I'll talk about like graph BI as a thing, a potential thing, where you have a Tableau for graphs, so to speak, or a Power, or something that marries that. I haven't seen anybody doing that like at a large level yet, but that's another area. If you think about democratization, is like, hey, I don't need to be in a separate tool. I just need a little bit of like, I just need PageRank on the side of what I'm already doing, or I just need something.
Yeah, I agree. I mean, I think there's been a lot of emphasis on graph queries, graph query languages, what we can do with them. But at the end of the day, a lot of use cases are probably more about what we can do with some lightweight application of graph algorithms, and then you find what you need and you take action. So I would expect to see probably over the year a lot more about graph algorithms and especially looking for patterns.
Yeah.
I think that's going to be a theme.
Well, and along those lines with patterns, like we're talking a lot about, insights and analysis. And I mean, of course, a lot of things are analysis, but, as far as the algorithms to like, okay, what's going on in this network and, surfacing some of that stuff. But I think the thing that I know we're going to see it. It has to be happening this year more than even, past years with a lot of this AI stuff is data cleanup and data transformation, right? Like talk about simple use cases. Not a plug for Paco or anything, but like entity resolution is the bane of my existence. I once worked for a company where they were trying to identify all the entities in news articles. And because they had to get it out, because it was the news, and some news articles were getting updated by the second, they had automated ways to do it. And it was just like cranking out the same entity a million times. And so I think I looked at just one use case, one. And on a very specific, it was a month, and it was during the presidency of Barack Obama. So now I'm like dating some things here. He'd been around. He was already president at that time. But in 1 month, this one article going around its AI, again, at that time, it was more machine learning than AI. I think he was created 50 different times in 50 different like ways of his name being spelled and created. And I was just like, yeah. So yeah, like, just a PSA to world, because I know these two are well aware. If you're using AI and it doesn't know which Paco Nathan you're looking for, and there are many of them, your AI will be wrong. Simple.
Like, I think then let's think about relationship resolution. So entity resolution, like you have to do that. Otherwise, throw your data out. Entity resolution. And then if we talk about patterns, how about some pattern matching and pattern resolution? Like this is a pattern that we've seen here, and over here it's exactly the same. It is the same group. It is the same, contextual document, just, reworded a little. So I think the potential there is just huge.
Yeah, I mean, everybody has their address books where you have a friend, but they have like 5 different email addresses over the years, and like I don't know, 6 different phone numbers, and even like Apple Contacts has trouble like resolving that on an iPhone. So it's a hard problem. It gets really hard though when you look at organizations that cross through different countries, different cultures, different languages. Like you might have a name in Arabic, but then there's 5 ways to transliterate it into English or Italian. So yeah, data quality. I'll drink to that.
Yeah. And, do you need to know what's a graph, or can you use graph to help you resolve some of those things or do the transformation from one thing to another? It's nothing sexy and innovative really, because like it's a problem and we've been trying to fix it for millennia. But it's now at the hands of more people, and I think we're
Right.
going to see a lot of people first accidentally getting into an AI situation where they didn't look at their data first. I think we're already seeing some bigger companies go through this. And
Certainly, yeah.
it's not so good. It's not so good. And now they have to go fix that because they're realizing.
Can I say something controversial, and maybe it's a prediction? I don't know. Maybe I'll be.
Yeah.
There's been a lot of talk about reasoning in the AI space, and obviously because of GraphRag, we talk a lot about AI when we're looking at all the new adoption for knowledge graphs. I will crawl out on a limb and say that I think a lot of the talk about reasoning is going to fall flat because there's so much money being invested in using large language models for reasoning. They're really good as syntax engines. They're not particularly good for reasoning. And people who've been digging in on the academic side have some pretty good arguments about why not. On the other hand, when you look at like neuro-symbolic AI, when you look about leveraging graphs and existing technologies, there have been a lot of advances. And when we talk about like causal graphs, it's getting much, much better. So I think that, definitely talking with enterprise customers, they're giving a hard eye roll when they see the press releases about, oh, our reasoning engine with a large language model is 56% correct now. That's a real hard eye roll, and I think that this year we'll probably see that play out.
Well, no, I don't disagree. I think like the first half of the year, and whatever that looks like, but the first half of the year, we're probably going to be talking a lot about improving the graphs that we do for AI, because that just seems to be falling short for all the reasons we just talked about. And so it kind of goes back to these old fundamentals, clean data, quality data, updating your data, knowing your data lineage, for goodness sakes, all of those kind of boring topics, but that are just absolutely essential in order to get good results. And then maybe Paco would agree with me that maybe towards the second half of the year, we'll go back to talking about good old analytics and understanding our data, and in the first place, not trying to predict something new, but just understanding what we already have. So we'll see if that's second half, maybe.
Yeah, I agree completely. I think an interesting thing that I've been watching when you look at the folks working in machine learning, especially like really popular packages like scikit-learn, there's been a lot of interesting advancement in how to evaluate machine learning models. And I mean, this is stuff that's really in production. I mean, at the end of the day, everybody wants to say they're doing fantastic AI work. Realistically, they're probably using, XGBoost or logistic regression or something. But there's been so much work lately in how to calibrate and how to understand errors and correct for errors, and just getting that sense of like really understanding what is your model doing, how does it fit the use case. There's been an advancement in the much smaller models for this, so I would see the analytics getting a big boost.
Sure, and I would double down on how to assess the models and even the outputs, right? So we hear all the time about graph rag or graph being used in RAG. It's not graph RAG specifically. And I've been doing a lot of experiments. And again, maybe this isn't earth shattering, but for those that haven't got there yet, you don't necessarily need to use the graph in RAG to get the benefits. Like even having the graph after the fact, you can actually increase the confidence you have in that response because now you have something to compare it to, which maybe you didn't before. And not only that, this was an interesting finding that it decreases the risk. Don't worry, I have a whole paper coming out on this stuff. But the risk, because AI, and for anybody that was at my Connected Data London panel, this is not news for you, because I talked about it a little bit there. there's risks when there are so many guardrails, and guardrails are good, right, on AI models. But if there are so many that it makes the AI response next to useless, and it's so vague that it's up for interpretations that make it risky, you've just increased your risk. Depends on the use case, depends on the domain, of course. But if you have a graph to add back in or to use the graph during RAG for that specificity, it makes your response potentially, again, for a use case that you need it for, less risky because it is now more specific with trusted data, which again, like these are really great things that you don't necessarily need to do this huge application for. Right? The graph can help even if you're not using it in a RAG.
I agree, and I think it's not just risk itself; it's practicality and how fast you can move as well. And sometimes, with a lot of guardrails, by the time you have approval to use a new model, your data may already be out of date. And how do you kind of move forward? And you can be trying to do the right thing and actually just make the solution completely impractical as well. And so if you can add in something to give more flexible, dynamic, because graphs can be dynamic, ways to evaluate, then move faster. So yeah, I think it's like even bigger than the risk alone.
I mean, over the past year, it's been really interesting because there had been so much emphasis on having like question answer coming out of like the chatbots, and a lot of emphasis on like information retrieval kinds of solutions. But not everything is a matter of asking a question and getting an answer. And not all answers out of AI applications need to be a Wikipedia page. But I think the services have kind of like taken a tact of they can be a little more cautious and basically generate Wikipedia pages as the results. And I think that'll only play out so far. There's a lot of other tooling, like really interesting work with reinforcement learning. And we were talking about causal graphs, optimizing subgraphs for causality, looking at like probabilistic circuits and ways to understand models more analytically, so that you have more trust in what you're getting out of them. So yeah, it's great to use LLMs, but I think there's a lot of other parts in the whole AI space that are being relatively ignored.
I think this idea of like getting 100 right answers and know, like if you get a million correct answers, with a safe model, if you're doing an answer question, like as a decision maker, what do you do with that?
Yeah.
And that's why, again, the analytics comes back in, or if you're using causal, so you can kind of say what node, what item has the biggest influence, and then I can make a decision. So it's interesting to think about. I hadn't thought of it this way, Paco, so thank you. But to think about the potential of, a million technically correct answers, and how that could actually stifle decision makers. Because at the end of the day, it's usually what someone has to do is they have to take what they get and do something with it. You've got to act upon it.
Yeah, and I think what you're describing is like, not to coin it this way, but like the next frontier of AI, which is, okay, great. You have a reasonable amount of correct answers. Now, what are you doing with that? What do you want to do with that information now that you have that? So, I mean, I think a play on some of the things you're both talking about right now is also, I do think a lot more folks are going to be starting to realize that AI is not the magical unicorn that fits every use case, even though it might work for all those use cases.
There's been this notion that you would have some AI tool that's super intelligent and gives you this brilliant answer, and an individual takes that and has all kinds of power because they're wielding this. That's like floating around Silicon Valley right now, and I think it's complete fiction. The notions of AI, like going back to the Macy conferences, were almost always the actual working examples were always geared toward like teams of people and machines collaborating together. And I'd also say that, like in enterprise, nobody makes any big decisions on their own. It's like any decision you make in enterprise, believe me, there's a review committee and there are 12 other review committees for that. So, I mean, the idea that you're going to have automation for decisions and like individuals, that never happens. And I think we have to get away from like having a super intelligent response to having like, well, how do, 3 or 4 or 5 people who are responsible for this thing, how do they eventually arrive at a decision, and how can they all like bring in their parts to bear on that?
Well, and how to play it out too, right? Like there's some predictive pieces to this that aren't necessarily to predict the right answer, but more to, well, give me the considerations that I need to think about from a perspective, which is the course of action that does one thing over another. Not one is better than the other, but like I need to measure these things. Like we all know from an enterprise perspective, there is no one direction that works and that's it, right? In fact,
Right,
that's the
right,
worst
yeah.
solution. If you only have one
Right,
option,
right,
that's a bad
right.
thing.
You're in trouble. Yeah.
You're in trouble.
Yeah.
So,
You need fallback.
being able, yeah, exactly. Being able to kind of understand how all of these little, tentacles of things interrelate and making decisions on that, I think is going to be really interesting to see.
A friend of mine teaches in a business school in the UK, and he did an exercise in his class saying, okay, break into teams. For the first half hour, each team is going to have a set of questions. You're going to produce a response. Break into teams, and for the first half hour, go out and work with your favorite AI service and come up with some answers for the questions that are posed. For the next 30 minutes, take all those answers and align them and then produce a report. And so it was really more a matter of how can you arrive at the consensus? How can you pull in multiple sources? How can you do editing? And the hilarious thing was like, as I understood the results was like, they got through the first half hour great. The second half hour, they were fumbling all over it. It's like, you're business students, you're going to have to do this. And I think that's one of the takeaways is this is the part that's hard.
I got to say that some of the smartest people I've worked with have been the best at brainstorming and getting information. It's not about status. It's not about having like the right answer from everyone they talk to, but they will talk to anybody usually to get more information and to help them see things from a different point of view. And that's where I think, a lot of the, as how I think about a lot of the Gen AI content. It's like, give me, the art of the possible, or, what's another way to look at this? And then, the person who is, or people, to your point, Paco, it's never one person they're trying to make a decision, can kind of weigh and challenge and use their experience to figure out what the best decision is. Because I think that, the fallacy that you're going to get a super smart AI give you the perfect answer. It's like, no, they're going to give you 100 answers. Good luck with that. And it's the same, you need to work with that. You need to work with, teams. And I think that's the way, good decisions, get made.
It's one of those things I think is, it comes up in all these conversations. There is, a realistic expectation setting piece, and then there's also a cultural piece. At the end of the day, we can talk about as much as we want on the AI and the analytics and the humans are using it, and therefore we are half the problem sometimes, right? or a lot of the problem, right? Like, okay, the AI gave me all the right answers. Now what do I do? I'm the human who, for some reason has made a dictatorship out of my startup. And now, oh no, that's not a good idea. Right. So like these are the things that, as sophisticated as we can get with the AI and the knowledge graphs and everything else that we can do in between. What are the humans doing with it?
Good point. I'm going to make a plug for a book that I'm reading right now called How to Know a Person. It's by David Brooks. And it should probably be titled like how to ask good questions, maybe. But so I'm very fascinated with this idea of how do humans ask questions and get to know each other and like have real meaningful conversations. So
nice.
So highly recommend it. And I really appreciate having an opportunity to talk to both Ashleigh and Paco and, practice my skills and having a conversation.
Well, if we're on this topic of book plugging, there's one, I think the title is The Half-Life of a Fact. I think it's a play on that.
Interesting. Okay.
That one's really interesting because it's really talking about like, how do you know what a fact is? Is there such a thing? And then all the human aspects of that. So that one, that's a really interesting one that I've come across recently. But I guess these are closing remarks. So Paco, do you have any suggestions?
Well, just to kind of, I mean, I'll give kudos to a friend, Jessica Talisman.
Oh yeah.
When we were all in London at the conference, she was quoting from Alison Gopnik that AI systems are cultural technologies, and she was, she had a talk about digital hellscape. That really a lot of the things that we're talking about, collaboration and understanding how to put information together. Librarians have been addressing this for a few thousand years, so we can probably look to cues about how to untangle cultural differences from some other disciplines.
Yeah, of course. Just a few thousand years. I mean, what do they know? That's sarcasm. Um, all right. So thank you so much for joining me in this recap of what might go on in 2025. Make sure you stick around on the channel, or if you're listening on podcast, make sure you keep following along to see if any of these prove out, where these mature, what might actually happen that we didn't even know about, all of these exciting things and more. So with that, I want to thank you very much. Catch you next time.